Today we are learning about trigonometric ratios, and if we take a look at our vocab sheet, we can see the definition says that a trig ratio is a ratio of the lengths of two sides of a right triangle. There are three basic trig ratios. They are called sine, cosine, and tangent, and as you can see, this video is going to focus on the ratio called cosine. And before we figure out what exactly this ratio means, we first want to look at a right triangle. So if we're given a right triangle ABC, we want to label our side lengths. So as always, AB is going to be our hypotenuse because it's our longest side length, as well as the side length that's opposite our 90-degree angle. So I'm just going to label this HYP for hypotenuse. And say we were focusing on angle A. So I'll mark angle A right here. And if we were looking at segment BC in relation to A, we could say that BC is the opposite leg. So we're going to record this as OPP for opposite. And if we look at segment AC, this segment is adjacent to our angle A. So we're going to label this adjacent, ADJ. Whoops. And so there we go. So this is how we would label our triangle in terms of angle A. Now, cosine. We're all wondering what this means. So I'm going to abbreviate cosine as just COS. So this is cosine. And cosine of angle A would equal the proportion of the adjacent side length over hypotenuse. So this ratio is adjacent over hypotenuse. Okay, so in this case, cosine of A for this triangle would equal AC, whatever value AC might be, over the value AB. This is for angle A. Say we were trying to find cosine of a different angle, okay? So if we have triangle ABC, but instead of angle A we want to focus on angle B, then first we want to label our triangle. So hypotenuse is still the same, but now in terms of the angle B, we have AC as our opposite side because it's opposite angle B, and BC is our adjacent side length because that's adjacent to angle B. So cosine, again, we said that this is adjacent over hypotenuse. So cosine of B, more specifically, cosine B would equal it would equal BC, let me just rewrite that, over AB. So that is your adjacent over hypotenuse. And so if we were actually given a triangle with side lengths, we would be able to find a specific number that would be our cosine. So in this triangle ABC, we have side lengths 7, 24, and 25. And if we want to find, as marked here, we have we have angle A, then we will find cosine of angle A to still be our adjacent over hypotenuse. But in this case, we can say that it is 7 over 25. So this would be our final answer. We could simplify this to be a decimal, but this is acceptable. So cosine of angle A would be 7 over 25. So if we go back to our first slide here, we have shown our triangle and how cosine of A is adjacent over hypotenuse. So no matter what triangle we are given,